In 2021, ransomware continues to dominate the daily news cycle. Many enterprises have been invested heavily to protect their high-value assets. While the high-value assets are protected, hackers continue to find different techniques to infiltrate and compromise high-asset. One such technique is to take over a low-value access device and use it as a pivot machine to find high-value assets, such as database and web servers inside the enterprise network. With the release of 3.4, RidgeBot introduces a post-exploitation capability to detect this security weakness. First of all, before the demo, I will explain how does RidgeBot perform post-exploitation and lateral movement. First, RidgeBot compromises a target. Using privilege escalation to gain root access, RidgeBot can deploy a botlet onto the compromised target. Second, botlet will scan and profiling the targets, collect the information, and then use weak password brute force attacks and RCE attacks to exploit them. Third, if the botlet can compromise a target, it will use SUID for Linux, or MS16032 Windows secondary logon service to elevate privilege. Last but not least, botlet will launch further the post-exploitation attacks from these compromised hosts. In this test environment, RidgeBot and compromised assets, 192.168.103.210, do not have access to the network in the secure DMZ zone. Compromised asset has two interfaces, one is connected to 192.168.103 subnet, and the other interface is connected to 192.168.107 subnet. In this diagram, first, RidgeBot will initiate an attack on the user Windows or Linux PC. Second, once RidgeBot is successfully compromised an asset, RidgeBot will pivot from the compromised host to find and exploit another targets. Third, in the secondary compromised host, RidgeBot is able to find and exploit high-value assets in 192.168.107 subnet. Let's see how we can set up RidgeBot to do post-exploitation and lateral movement. How to set up a task with post-exploitation. In this example, we will create a new task using a predefined full penetration scenario. Input the task name as post-exploitation demo. Set up the first targeted IP address, 192.168.103.210. Next, we will configure the parameters for post-exploitation. In the penetration menu, select post-exploitation. In the post-exploitation, enable lateral movement by toggling the switch. There are two additional parameters. The lateral movement depth defines the level of pivot. In this demo, we will select 3 levels. The max number of exploited hosts set the limit of exploited hosts. In this demo, we will set it to 21. Input the required target host IP address or range of IP address. In this example, the second target IP address, 192.168.107.180-200, and 192.168.103.203. Click on the Run button to start the task. After the task is completed, let's look at the result. RidgeBot has successfully compromised the first target at 192.168.103.210. Then it pivots and compromised the second target at 192.168.103.203. From this second compromised target, it found another subnet 192.168.107.x. RidgeBot is able to identify additional targets in the new subnet and successfully exploit those targets. Now, let's dive into the kill chain detail, to reveal how RidgeBot used post-exploitation and lateral movement to get access to the MySQL database in a server at 192.168.107.200. RidgeBot discovered an asset at 192.168.103.210. It found that this asset port 22 is opened. Using this open port, it found a SSH weak password vulnerability. Using the weak password vulnerability, RidgeBot is able to gain host shell access of the target. Because RidgeBot has host shell access, it can deploy botlet to this compromised host. The botlet in this compromised host starts to explore the network for new targets as specified in the configuration. It scanned and detected a specific target at 192.168.103.203. It found port 22 is open, and discovery that it has a SSH weak password vulnerability. It then exploited the vulnerability to get host shell access. Once it took over this host, it pushed a botlet into this host. The botlet started to collect information of the host, and found a subnet at 192.168.107, and then scanned this specific network for new targets. The botlet in the second compromise host found a new target at 192.168.107.200. On this target, it started to scan for attack surfaces. Found port 445 to be opened. Using this open port, botlet found a Windows SMB remote code execution vulnerability MS17010. Because the exploitation of this vulnerability may potentially cause the target to crash, botlet will stop further attack using this vulnerability. Botlet continued to look for other vulnerability. It found another open port, which is 1433. Using this port, it found a SQL Server weak password vulnerability. Using MySQL weak password brute force attack, the botlet is able to compromise this target. We just walked through an example of a kill chain sequence of how RidgeBot has compromised a low-value target, used it to execute post-exploitation and lateral movement, and gained access of a high-value asset in a different network segment. Thanks for watching.